So if you're an engineer, especially one who works close to the hardware with things like operating systems or embedded tech, well, you already know how important C is. It's not just another language. It's really the bedrock of so much modern technology. In this explainer, we're going to break down the absolute core concepts that every developer really needs to have locked down. Let's get right into it. You know, it's a totally fair question. We've got new, shiny languages popping up all the time. So why would you focus on one that's been around for over half a century? Well, the answer is pretty simple. Its age isn't a weakness. It's actually proof of its incredible, enduring power. And by the end of our talk today, you're going to see exactly why C is still the undisputed champion for anyone who's serious about system-level development. We're going to approach this like a construction project, what I like to call the builder's journey. First, we'll lay out the essential blueprint. Then we'll start building the program's logic. After that, we get to the real power tools, pointers, before we finish up with some advanced techniques and see where C is actually used out there in the real world. All right, let's start with section 1, C's essential blueprint. I want you to think of this part as pouring the foundation for a house. These are the absolute must-know fundamentals before you can write even a single line of effective C code. Okay, so what you're looking at here is basically the DNA of any C program. First up, you have that hashtag include line. That's kind of like bringing your toolkit to the job site. It gives you access to a bunch of pre-built functions. Then you have main function. That's the front door. Every single C program starts its execution right there. And finally, the statements inside those curly braces, well, those are the actual instructions, the steps in our blueprint. So once we've got our basic structure, we need some materials to actually build with, right? In C, our building materials are data types. They're the fundamental blocks that tell the program what kind of information we're going to be storing, whether that's a number, a letter, or something else. And here are our core materials. We use int for whole numbers. We use float for numbers with a decimal point. A char is for just a single character. And if you need really high precision for those decimals, you'll want to use a double. These simple types, believe it or not, are the foundation for all the data you'll ever handle in C. Okay, so you've got your materials, your data types. Now you need a place to put them. That's where variables and constants come into play. A variable, like int a, is like a box where the contents can be changed later. A constant, on the other hand, you see that const keyword? That's a box whose value is locked in. It can never be changed. So the key difference is super simple. One's flexible, the other's fixed. Let's move on to section 2, building program logic. Our foundation is poured, and we have our materials. Now it's time to add some intelligence to our project. This part is all about making our program think, act, and basically bringing our code to life. So how do we give our program that intelligence? We use something called control statements. Conditional statements, think if, else, and switch, let your program make decisions. You know, if this thing is true, then do that. Then you have looping statements like for and while. They let the program repeat actions, which saves you from writing the same code a million times. This is how you create truly dynamic behavior. Now, as your programs get bigger, you don't want just one giant messy block of code. It becomes a nightmare to manage. And that's exactly why we have functions. They're like little self-contained, reusable blocks of code that do one specific job. You just call the function, it does its thing, and maybe it hands you a result back. This is the key to keeping your code clean, organized, and way easier to work with. But what if you need to handle a whole list of values, like, say, 5 different test scores for a student? Well, instead of creating 5 totally separate variables, you use an array. It's just a single container that can hold a whole sequence of items, as long as they're all the same type. It's a super efficient way to keep related data organized and easy to access. All right, take a deep breath. We are now entering section 3. The power of pointers. And I really can't overstate this. For any engineer, especially when you're in an interview or doing any kind of system-level work, this is the single most important and most powerful concept in the entire C language. This quote right here, it really just says it all. Pointers are the reason C is so incredibly fast, so efficient, and can get so close to the metal, to the hardware. They're also the reason it has a bit of a reputation for being tricky. But let me tell you, mastering them is what separates a casual programmer from a serious C engineer. So what in the world is a pointer? Let's keep it really simple. A normal variable stores a value, right? Like the number 10. A pointer is different. It's a special kind of variable that doesn't store a value. Instead, it stores a memory address, literally the location where some other variable lives inside your computer's memory. Let's break this down. On the first line, we make a normal integer variable called a, and we put the number 10 in it. Think of a as a box with a 10 inside. Now on the next line, we create a pointer called p. But instead of putting a value into p's box, we use that ampersand symbol to get the address of a. So p now holds the memory location of a. It literally points right to that other box. So why do we go through all this trouble? Because pointers unlock everything that makes C so powerful. They let you manage memory on the fly. They let you write incredibly efficient code. They let you talk directly to hardware, which is critical for embedded systems. And they're absolutely essential for building advanced data structures. They really are the key to high-performance programming. Of course, with great power comes great responsibility. Pointers give you that direct control over memory, but it also means you have to manage it yourself. You use a function called malloc to ask the system for a chunk of memory. But, and this is super important, when you're done using it, you absolutely must use free to give it back. If you forget, you get what's called a memory leak, which is a classic and very frustrating C bug. Okay, we have covered the absolute core mechanics. Let's move into our final section, Section 4, Advanced Tools and Applications. In this last part, we'll look at a few tools for organizing bigger projects and then see where all this powerful C code is actually making an impact.
You see, as your projects get bigger, you need better ways to keep them organized. Structures are awesome because they let you create your own custom data types, bundling different bits of information together, like a student's ID number and their grade. File handling is absolutely crucial for saving data to a disk so it doesn't disappear when the program closes. And preprocessor directives are commands that give you more control over your code before it even gets compiled, which is a lifesaver in large projects.
So where do you actually find C out in the wild? Well, it's not really for building flashy websites. It's for the invisible foundation that almost everything else runs on. The operating system that you're using right now, almost certainly built with C. The firmware inside your car, your microwave, your Wi-Fi router, that's all C. The deep, fundamental systems that keep the internet running, that's C too. It is the language that builds the world. So let's wrap this all up with the key takeaways. Number 1, C gives you absolutely powerful low-level control over your computer's memory and hardware. Number 2, if you're an engineer and you're heading into job interviews, mastering these concepts is pretty much non-negotiable. And finally, at the end of the day, it is still the undisputed language of choice for any kind of serious system-level development. So we've laid out the entire blueprint for you, from the basic foundation all the way to the advanced power tools. C is a language that truly lets you build almost anything you can imagine from the ground up with maximum performance and total control. So the only question left to ask is, what are you going to build with it?